And it is also possible for us to model the machine and to understand if a machine is broken down, if a machine is misperforming, underperforming, then what should I do? How should I modify my plan so that overall my factory runs as scheduled or as planned? And that's a critical part of it because digital plays a large role in that. And again, simplifying and making it very high level, there is a lot to it. And simply putting a box and saying all of this is part of it. But there is a lot more that goes into doing this. Product quality. Give you a quick couple of examples. Many of you have two-wheelers. A lot of those two-wheelers have stickers on the side, right? On the sides of this two-wheeler, the front will have a small little logo. How many of us have paused and thought about what happens if the color combination of the stickers is incorrect? What happens if the logo sits upside down, right? Now, there are workers on the floor. I visited a two-wheeler factory where we have Poland a few weeks ago. There is an army of workers who look at these two-wheelers as they are rolling off the line to make sure that the stickers are, if it is black, then I need a red and yellow combination on the side. If it is blue, then I need a blue and silver combination. And so on. So the stickers are different, branding is different. The logo has a certain orientation, you have to fix it. All of this is done manually, and of course, if the worker misses because of eye fatigue or whatever, it's that much money. Another example I can give you is those of us who have cars. We like the car's surface to be nice and shiny and smooth. I visited an automotive factory nearby here in Bangalore, where workers come every day in the morning and build a muscle memory. They take their hand, they place it on a weighing scale and press it till the weighing scale reads 2.5 kilos. So that pressure they build 20-25 times, they press the weighing scale till the muscle memory is in their hand. And that's the pressure they apply on the car with a white glove to touch the car and see whether there are any dents or knobs on the car surface. Right, that's the kind of thing that goes on in quality. Now, this is an easy thing for a computer to do. There are multiple techniques, I won't get into that. But the point is, some of these are very engineering-specific solutions which can give you better quality outcomes. And using the material spec, this is really not sorry. The finished goods parameters, the customer service parameters, it's possible for us to identify areas in which. So this one essentially is what I have written there is Internet of Things and computer vision. So you can actually connect up multiple devices that look at vendor components, understand whether those vendor components are adequate in quality or not, and wherever it is possible to pass it. This bit which I already mentioned, you can actually capture the process specs. Like one of the key measurements of manufacturing process reliability is something called CPCPK. CPCPK is essentially a statistical quality control measure, and it has to be within a certain rate for you to say that this is okay. Now, it is possible with digital twin again to predict what will happen in the next step based on the parameter of the previous one. So there, the digital twin will act, and the finished goods again based on customer service and the finished goods specs. It is possible for us to capture what is happening at the finished goods. Today, if you go to an automobile assembly line, you will see something like a cage which has like maybe 150 tube lights, right? Powerful these lights. The vehicle is passing through it, the workers are in the middle of that cage, and they check the vehicle for any visual defects. So that's the kind of light they need to put on the vehicle for them to make sure. Now you can imagine the eye strain of the workers that are standing there. They are there for 8 hours. Sure. The eye strain is tremendous. So if there is a way that we can eliminate or alleviate this kind of stress for the worker, I think everybody will be very proud. Not to replace the workers. Somebody I think I read a couple of days ago said that people using AI will replace people that are not using AI. AI will not replace people. But those people that are familiar with, comfortable with using AI will replace people that are not. So the future does belong to those who have the skills in artificial intelligence and applying it to various business applications such as this. The last augmented augmented machine maintenance. Typical machine maintenance are driven by OEM manual, maintenance policy of the organization. Of course, the maintenance personnel that is deployed on the various machines, and of course, the machine logs that come onto the machines themselves. So you look at all of these data and you figure out what you want to do in terms of maintenance. Problem. So, what I'm saying here is it is possible for us to read all these things. I'll give you an example. This may not illustrate it. So I was working in a big refinery up in North India, and the refinery has like literally kilometers of pipeline, and the pipelines are valve and various other control features to enable the flow or stoppage of the gas or the refined oil that is going to petrol. So it was difficult for the new maintenance team, which were all young engineers, 25 years old. They had no prior knowledge of what was going on in the pipeline. They had no understanding of the OEM equipment. But it was critical. Without the pipelines, the factory would stop. So the OEM actually created at that time, as I talked about 2005 to 2006, a video which was running on their computer. The iPads were not yet available. They created video instructions of what is going on in the pipeline, what kind of maintenance has to be done on the valve, any other control equipment that was on the pipeline, along with the maintenance manual that was integrated into that video. Right? So they used to point out the figure and say, this is what this part is about, this is what we need to do to maintain it. And the OEM actually gave them all these videos. Now we collected all these videos, put them in an activity. This is pre-AI, right? Pre-AI documentary. Now just imagine there is a computer now that enables you to identify the content of these videos, to merge the video content along with the drawings, the engineering drawings, the maintenance drawings, and throw out a set of instructions to an engineer who is 24, 25 years old to do what he has to or she has to do. This kind of power with the engineer, now today with an iPad, the solution is kind of taken off. It's become a massive hit with the client because of the usability of the solution. All we did was bring together multiple things, and it was a constraint environment where young engineers did not know what to do. The solution kind of addressed that problem, and today they run around with iPads all around their field, all these kilometers of pipelines still maintaining the ground. And the technology is now far advanced than what we started off with. So it is a journey, and in many cases, bringing in the computer into the maintenance, into the business process, actually enables the business process to function a lot better. So I hope I gave you a quick overview of what this is all about, how using AI in manufacturing has helped, and share some of my examples, my experiences. Thank you so much.
Questions? How do I normally better off answer for that's how your opportunity go on. So with AI, which of these three are most effective?
So,
which is the order?
So, both in the order of priority for business, better is the first, I would say. Faster, it's still garbage and garbage out. So the more garbage you shovel in, the faster the garbage comes out. So I would put it as the last. The better, cheaper, and faster would be the order of whichever.
Knowledge they should be teaching to prepare the workforce for the kind of work that you're talking about. So our colleges, our schools, we don't seem to be there yet. So what is it?
So good question. A lot of our students, I keep, both my boys are just about entering university. One of the things I keep telling them is never let go of mathematics, whatever else you do. So one of my kids is doing economics, the other just finished his graduation in mathematics. But both are in touch with me. So my advice and suggestion to children who are going into college would be to understand that math forms something of a bedrock science, right? So you need to have that. I see things like biostatistics, bioinformatics in colleges now. So a lot of biology students, when I studied, biology was a subject you went to fit it like maths and physics. But that's no more the case. Right? You have to learn mathematics. So in that sense, there is a certain emphasis in mathematics that is coming in, which I think is good. Even both my sons, I am an engineer in India, and both my sons declared one day that they will never do an engineering or an MBA. So that's not problem. Kids are doing these days. Right? So even if you're not interested in an engineering degree, even a science degree, you need mathematics. That is wrong. Are they teaching enough of it? My answer is probably not. Right? Those kids that are naturally inclined towards numerals, mathematics, and so on, numeracy skills, I think they do a very good job. But what is happening in technology is that technology has this habit of meeting you more than halfway. So a lot of the stuff that is coming out now are intended for use by people who are not able to understand what's going on. Right? To kind of make it, they call it democratization in various words are there, but it is more usable, very simple. So technology then will meet some of these demands. But it is important for kids to be sensitive and accepting, and this will help them. That's here as well. Again, institutions are not doing a great job. This is my personal.
I just want to understand. You showed the absolute digital twins. So now you have a box. Couple of digital twins.
So, yeah, so good question. So the digital twin is not like a monolithic structure. So I've just taken it in a simple slide to show you that it can be encompassed as a digital twin. Now, what is a digital twin in a manufacturing context? Is you typically have at the highest level a supply chain planning. So you get the demand from the market, you plan at that level. Then you have a factory planning, which is the next level. And then you have a manufacturing execution system, which is the next level, which is basically all the programmable logic controllers and the supervisory control systems that are sitting on the machines. So you take the data from them, you understand what is going on the machine, then model it back into the factory plan, saying, okay, I had to manufacture 500 pieces of this product yesterday, but I really ended up manufacturing 320. So the remaining 180 is going to be planned, so the factory planning takes care of it in the next planning round. Why the 180 did not get manufactured is answered by the manufacturing execution system. Was it a material problem, machine problem, quality issue, workers didn't work, productivity was wrong? There could be any number of reasons. So all of that comes out of manufacturing execution system. So you take the data from all of this, you put it in what we call today a data lake. It is like an enormous collection of all the data that you are working with in the factory. The data lake is just a storehouse, everything is in that. You then have to build algorithms of intelligence and so on, which then tells you that these pieces of data correlate to this. You had a worker issue yesterday, absenteeism, for example, and you have 180 pieces short. And it could change, as you can imagine. One day it could be a machine issue, one day it could be absenteeism, another day it could be vendor and supply. So any of these different reasons can correlate ultimately to a loss of production. And then you figure out how often are these problems happening and what should I do? What is the action? Should I take care of absenteeism? Is that higher problem or is it a vendor material issue? In which case I have to tackle vendor quality problem. So it gives you that kind of direction. So when I say digital twin, and there are more or less all the time what in economics they call the lead indicator. Right? Something happens first, and then following that a series of events happen. So when you catch that initial event, it is possible for you to predict that the next may happen, and this may not, and this may happen, and this may not happen. And that prediction is what I call as digital twin.
I understood that an AI manages an entire life cycle of a product.
Sorry, I can't hear you clearly.
The AI helps in managing the entire life cycle of a product.
Yes.
Once the life cycle of a product is done, it's completed. Say the life cycle of a car is done. So after the life cycle, we are going to scrape it, right? So once when we, at the time of scraping, is there any AI or which helps to reuse whatever present in the product, or if it's so, how long, kind of?
Have started accepting what they call the extended supply chain responsibility, whatever you want to call it. So if you use a piece, or if you use a product like a toothpaste or a toothbrush, and today you must have read in the newspapers that toothbrushes cause a lot of microplastics to go into the sea, right? And we all regularly use toothbrush and throw it in the waste bin and throw it. So they're saying that if you finish using anything, a shaving canister, a shaving blade, brush, toothpaste, you give it back to me. As a manufacturer, I will take it back and I will recycle it. Now the question is, when you send out material from your factory to the end consumer, it is from one large factory to many millions of customers like us. But when many million customers have to send it back to one single factory, how do you achieve that? Right? So it's still, in a sense, a reverse supply chain discussion that is going on. I don't think there is any definitive answer here. But the answer on a more complex product like a car is the government is bringing in the rule saying vehicles older than 15 years have to be scrapped. There are technologies available today called telemetry, which can tell you how many kilometers your car has done, what is the wear and tear of the various parts of your car, and so on, which is very useful for the people in the logistics industry. But it can also be used for this kind of end use application. Saying if your car has done more than 150,000 kilometers, it's good as scrap, you have to sell it. You have to throw it away. So it is possible for somebody, maybe the suitable protections, the regulatory authority like an RTO or somebody to understand how many cars are there in the city area that are older than 15 years, that have been registered in the year 2008 or earlier. And then call those people back using the same methods, trace the car, send a message to the current owner and say, get your car back, it's good as well. So, answer is yes, but it's not yet a full developed solution